Let's get started on finishing up the model. We'll start off by importing an oxygen atom. We'll move it close to the first of the two unbonded carbons, and we need to reorient it so that way two of our bond points are more or less facing two of its bond points. Use the move tool and the rotation circles to do so. You can always deselect and start the move over again to reorient the move axes. You'll want to get the bond points of the oxygen atom close to the two bond points of the carbon atom, though you don't want them too close, as this might interfere with the loft that we'll use to connect the two. The atom still might be too close in this case, but we'll try using the loft tool anyways. The loft tool is under the construct tab called loft. Click on it and then click on the two faces you wish to loft together. Well, in this case the loft tool didn't create a shape and gave us an error. So let's try reorienting our oxygen a little bit. We'll move it a little further away. Let's try using the loft tool again and see if it works. So once more, select the two faces you wish to connect together, and it'll create a loft between the two. Make sure to deselect your previous loft by clicking on the screen or pushing escape on your keyboard, and do the same with the second bond. So once again, we click on loft under the construct tab, and we select the two faces we wish to loft together. Push enter to accept the loft, and then make sure to deselect the shapes you used to loft by clicking on the screen or pushing escape on your keyboard. We still need to add another oxygen atom, so we'll insert another oxygen atom. We can just use the snap tool to quickly attach this one to the end of the carbon chain. There we go. Now we need to add a spare electron. This is called a p orbital electron. We can insert that from the same file. And once more, we can use the snap tool to quickly connect it to a free bond point on the oxygen. This spare electron then ionically bonds with a sodium atom, so insert the positive sodium atom from the library, and now we'll just use the move tool to move it into place, and then to reorient it so the text on it is legible. To show that the sodium atom is ionically bonded to our oxygen, we'll just get the sodium atom to be close to the oxygen bond. Last, we need to add the last couple of hydrogen atoms to this molecule, bringing the total number of hydrogen atoms up to 35. So we'll insert two hydrogen atoms from the library. Make sure to move them out of the way so they're not stuck in each other. Then we'll use the snap tool to quickly place them onto the unbonded bonds of the last two carbon atoms. And there we go. We have now completed the model of our sodium stearate.